Let's explore Level Order Traversal, a breadth-first search-based tree traversal technique. In Level Order Traversal, nodes are visited level by level, starting from the root. This approach ensures that all nodes at a given level are visited before moving on to the next level. As you can see in the illustration, the nodes are traversed in the order of 1, 2, 3, 4, 5, 6, and 7, following a level-by-level approach. So, what exactly is Level Order Traversal? It's a breadth-first approach to tree traversal, which means it explores all the nodes at the present depth prior to moving on to the nodes at the next depth level. It visits nodes level by level from top to bottom, processing all nodes at the current depth before moving to the next level. It uses a queue data structure to keep track of the nodes to visit. As shown in the binary tree on the right, the output of Level Order Traversal would be 1, 2, 3, 4, 5, 6, and 7. Let's discuss the key concepts behind Level Order Traversal. The first key concept is the queue data structure. Level Order Traversal relies on a first-in first-out, or FIFO queue, to track the nodes. Each node is processed immediately after being dequeued, and its children are enqueued for later processing. The other key concept is level-by-level processing. Nodes are visited in order of their distance from the root. First the level 0, which contains the root node only, then level 1, which contains all the children of the root, then level 2 containing all the grandchildren of the root, and so on. This provides a horizontal scanning pattern through the tree structure. Here are the algorithm steps for Level Order Traversal. First, create an empty queue and add the root node to it. Then, while the queue is not empty, dequeue a node from the front of the queue, process the dequeued node, that is, add it to the result, and enqueue all the children of the dequeued node from left to right. Finally, return the result list containing all the nodes in level order. On the right is a Python implementation of the algorithm. The function Level Order Traversal takes the root node as input. If the root is none, then it returns an empty list. Otherwise, it initializes a result list and a queue with the root node. While the queue is not empty, it dequeues a node from the front, processes it by appending its value to the result, and enqueues its left and right children if they exist. Finally, the function returns the result list. Let's walk through an example execution of the Level Order Traversal algorithm. In the first step, the queue is initialized with the root node, which is 1. The algorithm starts processing the queue. In the next step, node 1 is dequeued and processed. Then its children 2 and 3 are enqueued. The result at this point contains only the node 1. In the next step, node 2 is dequeued from the queue and processed. We are now ready to enqueue the children of node 2, which are 4 and 5. The current result contains nodes 1 and 2. Next, node 3 is dequeued and processed. Then children of node 2, nodes 4 and 5, are enqueued. After completing the Level Order Traversal, each node in the tree has been visited and processed. On the left, the tree is displayed with all nodes marked as processed. The final traversal order is 1, 2, 3, 4, 5, 6, and 7. On the right side of the slide, you can see the level-by-level output. Level 0 contains node 1, Level 1 contains nodes 2 and 3, and Level 2 contains nodes 4, 5, 6, and 7. The final result is the list containing all nodes in level order, which is 1, 2, 3, 4, 5, 6, and 7. Level Order Traversal has several applications and variations. Some applications include level-by-level processing, which is perfect for problems that require processing nodes level by level, such as finding the minimum depth of a binary tree, or creating a level-based view. Shortest path finding, where breadth-first search guarantees the shortest path in unweighted graphs, making Level Order Traversal ideal for maze solving and navigation problems. Serialization and deserialization, where trees can be efficiently serialized and deserialized using Level Order Traversal format, which is useful for data storage and transmission. Some variations include zigzag level order, which traverses levels in alternating directions, left to right, then right to left, adding visual variety to the traversal. Another variation is level grouping, which returns nodes grouped by the respective levels, useful for visualizing the tree structure or creating level-aware algorithms. Bottom-up level order processes nodes from bottom to top, starting with leaves and ending at the root, which is useful for certain dynamic programming problems. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.